Welcome to the Space Gas training video. In this tutorial, we will guide you through the plastic fuse elements, one of the new features in Space Gas 14.2. Plastic fuse elements are characterized by a tension and/or compression force limit. Exceeding this limit causes the element to yield axially in a plastic manner. This feature is extremely useful for various types of structural analyses, such as strut and tie models. In these models, certain struts or ties might exceed their capacity and redistribution becomes necessary. Referring to the diaphragm displayed on the screen, it is modeled utilizing the strut and tie method. This approach features orthogonal members that represent the steel and diagonal members that signify the concrete strut. The objective is to analyze the redistribution of forces, bearing in mind that the steel force cannot exceed 40 kN in this specific structure. Under these circumstances, employing plastic fuse elements is considered ideal for modeling purposes. You can set a member as a plastic fuse member by double-clicking it and choosing plastic fuse as the member type in the properties form. Remember, two unique attributes need consideration: the fuse tension limit and the fuse compression limit. As stated earlier, the axial force in the member won't exceed these limits. In our example, we'll set the tension fuse limit to 40 kN because in this specific model, the steel tension won't exceed 40 kN. Additionally, it's important to note that a fuse force limit set to 0 is treated as if it were infinite. In other words, this implies an unlimited axial capacity in that direction. Let's analyze the model and observe the results. By enabling the contour of axial force in members, we can clearly observe the distribution of force and identify where their capacity has been exceeded. Evidently, this new feature is beneficial and enhances the modeling and analysis process. Thank you for watching this video.